So we learned about writing formulae, now we're going to try and use that in writing some balanced equations. However, another important skill for what we have to do in chemistry is to be able to record observations that help us make the right inferences that we then use to write our equations. So for the first one, we start with barium nitrate and sodium hydroxide. The reason I can put those formulae up so quickly is because they're written on the bottle. So I'm not asking for anything magical yet. They were written on the bottle, so I can just write them out again. The first step was to carry it out, and then the second step is to write some observations. Both of these are what we call colourless, clear solutions. Colourless, clear solutions. It means they didn't have floaties in them. They weren't all cloudy or milky. That's what clear means, which is what all solutions must be. All solutions are clear. They can be seen through. They were colourless because they didn't have a colour. Sorry to be a little bit patronising on that one, but we need to know the difference between clear and colourless. These are good examples of that. When we mixed them though, they were no longer a clear colourless solution and a clear colourless solution. What happened? Went cloudy. Cool. So cloudy would be what we'd say it would have a white precipitate in there. Okay, it was now a suspension. So a suspension is where there's something insoluble or partially soluble in that liquid. Because it was made from two solutions, we call it a precipitate. So the type of a reaction in this case is called a precipitation reaction. These are going to be very, very important for your internal, because precipitation reactions are a really good qualitative test for what is present. Qualitative comes from the word quality. It's just saying what qualities does it have. Okay? So what is it? Not how much is there. So now we have to try to work out what could that cloudy stuff be. And if I have a look at these, they are both a metal with a non-metal basically. So what type of compounds have we started with? What types of compounds? Are they molecular or ionic? Ionic. So we're pretty sure that there must be barium ions. I'm not going to put the charge in yet, I have to work that out. There are nitrate ions, there are sodium ions, and there are hydroxides. Now, you're not given a table of ions this year. You're expected to remember some important ions and you're expected to use the periodic table. The giveaway on this one is barium. Barium is in the same group as calcium, magnesium, and beryllium. Well, you should know the charges of magnesium and calcium ions. They're both 2+. They're in the second group. So therefore, it must have 2 valence electrons. This is why we did the stuff on atomic structure. So barium must be 2+. Well, if this has no charge, and you need 2 nitrates, what's the charge of nitrate? You need 2 of them to cancel out the 2. Negative 1. And sodium is in group 1. Which means it has 1 valence electron. So what's the charge of a sodium ion? Brilliant. There's only 1-to-1 ratio there, so this must be -1. Now what we're going to do, if it's a precipitation reaction, it means that one of these 2 combinations of cations and anions is insoluble or sparingly soluble. For those who did physical science last year, you might remember that all sodium salts are soluble. So therefore this combination is actually soluble. Sodium nitrate is actually very, very soluble. But the other combination of ions that can happen is not. Barium hydroxide is only sparingly soluble. It doesn't dissolve very well at all. So our products are going to be sodium nitrate, which is actually, we can't see, it's dissolved in there, and barium hydroxide, which is our cloudy suspension or our precipitate. Okay, so it's barium hydroxide in a suspension of sodium nitrate solution. So we need to show that with an equation. Started with the first thing, so that's pretty good. You notice I always leave a space in front of everything so I can change the quantities. Okay. Now what we looked at before, barium hydroxide, we need how many hydroxides in it? 2. Excellent. So BaOH twice, because it's all of the OH, not just the hydrogens that I'm doubling, I put the OH in brackets. And the other thing is sodium nitrate. Well, they are the same but opposite charges. So that's just Na-NO3. Hopefully that's still on the screen of the video. We can see some things that are not balanced in there. The most obvious thing to me would be that there's 2 nitrates in this, but how many in this one?
3.
Nitrates, not just the oxygen. Okay, there's only 1. So I need there to be 2 nitrates on each side. So I'm not allowed to change the formula of anything. This is why I write it in black. Normally if I was doing an assessment, I can use black and I can use blue. So I'm now going to use my blue to change the quantities of things. I'm going to balance it out. 2 nitrates there, and if I want 2 nitrates, I need 2 of all of that, not just the nitrate. Okay, was that your question?
Yeah.
Okay, cool. So I'm going to have a big 2 there. So I've got 2 nitrates, but I've also got now 2 sodiums. I've now got 2 sodiums by doing that. But how many sodiums are on this side?
1.
1. So if I want there to be a second one, I have to have 2 of all of that. But that gave me 2 hydroxide ions. Is that good or bad?
Good.
Good, because there are there. And that's balancing. And the reason that we call it balancing is you tend to be like you're on a seesaw till you get it balanced. You go backwards and forwards, changing the quantities of things until it is perfect. So that's an example of how I'd like you to write out the first one. You've got the 2 things that are combining, what you observed. If you're not at the step of knowing what's made, write down what would be there. Write out your equation and balance it. Any more questions before I turn that off?